Welcome. The purpose of this video is to give you feedback on the weighing project so you can improve your next project, and then tell you about how I graded or scored your project. Let's begin with the feedback, and if you'd like, you can find this document online. I'm using Google Docs, and I made a tiny URL so it's easier to enter, so there it is. Feedback number 1 deals with the scientific method, and in the conclusions of your report, what you always want to put there is data-based results. So examples for the weighing project: the average accuracy of my scale was plus or minus 4%. The average precision, and here you'd use standard deviation, plus or minus 5 grams. The linearity is shown in figure XX back in the report. The average time constant is 17 seconds. What you want to notice here is every one of these is a measurement. What you want to avoid in science is judgments. Don't say things are good or bad. Don't say they're right, wrong, awesome or awful, or give personal opinions. It's all about giving numbers like this and let other people decide what they think of these numbers. Two ideas that have really helped me: if you read Cargo Cult Science, just Google this. It's an essay by Nobel Prize winning physicist Richard Feynman. And he really gives a sense in here of what science is about. I learned a ton reading this essay. Tip number 2 is decide to be a critical thinker. And that's simply deciding, I choose to be open-minded, especially when ideas contradict what I already think is true. I choose to base my decisions, beliefs, and choices on data, evidence, reasoning, and knowledge. And I choose to be skeptical, but of my own beliefs and of traditions and what everyone seems to believe is true. And of course, those of you who know me know I call these the 3 pillars of critical thinking. And critical thinking and the scientific method are the same thing. Why do this? Well, the human brain, it's hardwired to prejudge things, to have bias, to jump to conclusions. Otherwise, we'd be constantly having to think too much. And to circumvent these natural flaws in the brain, what you want to do is apply critical thinking when you're doing engineering type things or scientific research type things. Feedback number 2 is also about the scientific method. Very simple idea. Be sure to totally understand how to use your technology. And to illustrate this, I'd like to share with you a story of a big mistake I made. So when I was doing my PhD research, I needed to generate oscillating airflow through an orifice. So I want the air going back and forth through this orifice. So I came up with a piston here that vibrated back and forth and produced the desired airflow. And I needed to measure the position of this piston. So I got this really sweet proximity sensor. And I talked to one of my favorite profs and I said, how would I measure this? And he goes, go buy this device. It works great. So I went and bought this and I hooked it up and started getting data. And the data looked really good. But months later, I discovered there was a problem in my data, and what had happened is I'd never really figured out how this worked. And it turned out that the metal that it was looking at, the metal of this piston, had to be a certain alloy of steel in order to get accurate data with a given calibration constant. And I never knew this because I hadn't read the manual. And so I wasted months of time by not understanding how my instrument worked. So when I heard students reporting the data was off by 50 to 100% with the force sensing resistor, I immediately suspected that the real issue was the student had issues with understanding either calibration or understanding how an FSR works, because I know I made this big mistake for months. And so the why is fairly straightforward. If you don't understand the technology, your data and all your conclusions will be off. So how do you do this? Well, you study the data sheet, or if there's a manual, study that, figure it out, talk to knowledgeable people. And the key thing is understand the physics of your technology. And then the last thing you can do is run checks, validation, and tests. There's about 100 things that can go wrong, and what you want to do as a good researcher or a good scientist or a good engineer is troubleshoot and make really sure that you know how to use your technology. Feedback number 3 is about the process approach. Now, why? Well, very simple idea. Baking a great chocolate cake is rather simple. Find a great recipe and follow it. And doing a really well done experiment as an engineer and getting a high grade in this class is just like this. There's a recipe or set of steps that will give you great results for an experiment. And it's probably better to say, if you don't do these things, your chance of getting good results is very, very low, because it takes time and practice to learn how to do these things well. But there is a recipe nevertheless. What I want to do is follow the proven step-by-step process for designing, executing, and reporting an experiment. So how do you do this? Well, look at the website resources on how to design an experiment. This is the stuff I have up on my website. Summarize the process in your own words. Practice using the process. And you can do this over and over. You can literally, once you learn how to design an experiment, design and do an experiment in less than a half hour. Get feedback from any of your teachers. All your teachers have gone through research and publication, and they understand the scientific method. And key thing is do the process in iteration cycles. Feedback 4 deals with the literature review. And what is a literature review? Well, again, it's a well-defined part that should show up in any final report on any experiment. And what you do in here is you teach or explain the key foundational knowledge relevant to this project. And you write for your target reader. Why do you do this? Well, whatever you need to know has already been figured out. There's such an incredible amount of literature. So the benefits of doing a literature review, it gives huge credibility to your final report. You learn a huge amount from doing your project. And it builds your capacity to learn. You develop skills for being a lifelong learner. So how do you do a literature review? Well, the process is very straightforward, and I'll try and build a video to show this in more detail, but for now, let me give you 3 steps. Number 1, set a time limit. On a 10-hour project, I would probably spend an hour and a half to 2 hours on a literature review. No more, no less. And the reason is I got to get the project done, but I want to put in enough time so I get some value out of the literature. Then I do a diamond, step 2. And the basic idea is this. I come here and I ask the question, what if people already learned that would be super helpful to me on my project? And I start talking to people, looking at the internet, looking in books, and finding all kinds of resources and all kinds of ideas. Then I ask another idea. Of all these things that are known, what are the very best ideas? And so I select the very best things. And then what I do is kind of converge this down. And these very best ideas right here are what I put in my literature review. Feedback 5 is follow the writing recipe. And this is the IMRAD structure. Why do you do this? It makes writing really easy. You don't have to think. It makes reading very easy. Your reader knows exactly where to look for whatever they're trying to find. And it builds a huge amount of credibility to your technical work because people see the structure. How do you do it? Well, there's a basic recipe. And let me walk you through this really quick. In your intro, tell people here's the present situation. Here were the goals of my project, and here's why reaching the goals is beneficial. And then tell them also, here's a summary of what human beings have already discovered that is super relevant to this project. In your methods section, tell people here are the steps I took to reach my goal. And again, write for your audience. A lot of the detail, you don't need to put it in there because good engineers understand these details. You tell them the main ideas. Here's the key things I did. Results and discussion. Here are my data. Here's how I interpreted this. Here's how I made sense of it. Here's what you want to notice. And just describe the results in terms of the data and discussion. In your conclusion, tell people, here's a summary of the results that will be useful to you. And just lay it out for them. Give them measurements. Give them numbers. Quantify. And avoid judgment. So, any details you have, why, stick these in appendices. And here's some you might use in this particular class. Lastly, the abstract is like a little mini report. So you put all the key ideas that are in your report, but you use kind of one sentence. So in one sentence, here's the present situation, here's my goal. And then maybe another sentence, here's why reaching this goal matters. And then here's the basic methods I took, and here are my final results and why these results make a difference in the world. Thank you. That concludes this video. I hoped you learned a few things. We'll see you next time.